Hi everybody, my name is James Heller. I work at Apartment 304 on cloud architecture, application development, and DevOps. But in my free time, I like to automate Halloween decorations, and I'd like to share a scary story called Halloween Spooktacular Fog Machine Madness. Like many scary stories, ours begins with a spooky house, and in that house lives a mad scientist, that is me, who has a fog machine that he uses to make a spooky fog-filled graveyard. But there is a problem, because the fog machine runs on a timer, and if that time interval is too long, then trick-or-treaters can come and go and they don't see the fog. And if the interval is too short, then there can be lots of fog but nobody around to see it. So I had an idea to run the fog machine when trick-or-treaters are close by. To do that, I needed to build a custom remote control for the fog machine. I needed to detect when trick-or-treaters were nearby at the bottom of that hill, and I needed to send a signal from the bottom of the hill all the way up to the fog machine at the top when those trick-or-treaters are close by. Looking at the remote, that took a little bit of hardware troubleshooting. The back of the fog machine has a 5-pin MIDI port, but I didn't know what pins did what. So I got out the handy-dandy multimeter, and I started probing and trial and error, guessing that if 2 of them were connected, it would probably trigger some fog, and I discovered a few things. The fog machine has 2 states. There's the cold state when the 5th pin has 0 volts, and the hot state when the 5th pin has 3.7 volts. I also learned if you ground the 4th pin of the fog machine, it makes fog, so problem solved right there. But those pins are dangerous to connect to a microcontroller because the voltages would fluctuate quite a bit, especially when switching from the high to low state. So I had to make sure I handled that in a circuit. Looking at the circuit, you'll see that there are 2 loops to that circuit. There is the green loop, which handles the hot-cold status, and the red loop that handles the fog machine making the fog by grounding out that 4th pin. You'll notice that each loop starts and ends on the same side, either microcontroller or fog machine, and the only time they cross over is at a switch, and that switch is a transistor. We're using those transistors as a buffer so that the 2 sides don't connect directly to each other. And you can think of the transistors like light switches. They start in the off position, but when a signal comes in, flip the switch, closes the circuit, and the circuit's able to run. But then when you want to stop it, you just stop the signal, and that switch goes back off. Looking at some code that drives this, a few things to note. I used GoBot to interface with the hardware pins, and errors and contexts are omitted for brevity. There are 2 main pieces to the fog machine GoBot. The first is the driver, which handles that low-level hardware pin interface, and then there's the controller, which handles the higher-level question of, should I run fog? Here we have the driver when we start, and the first thing we do when we start is we poll for the status from the fog machine. We do that by reading that ready input pin, and we get the value. And if that value is the hot state, then we know that the machine is ready. And if the value is not the hot state, then it's not ready. So we set that, and then we wait. And we usually pause for about 250 milliseconds between polls. That way, if the state changes, we'll figure it out pretty quickly. The other part of the driver is the run fog method. The run fog method first checks if the machine is ready. If not, it returns an error. But if the machine is ready, then we write to the fog output pin the high value of 1. That closes the red circuit there, and that grounds out the 4th pin on the fog machine so that the fog machine can make some fog. We then wait for a duration, usually 10 or 15 seconds of fog, and then we need to stop the fog. And we do that by writing the output pin to the low value of 0. So we know how to, sorry, that was the driver. I'm losing myself. So we have the driver. We still have the controller. The controller handles that high-level question of when should we run the fog. So the first thing we do in the controller when it starts up is we start the driver, and that starts that polling for the fog state. And while that's happening, we then listen for fog signals, and those are external signals that we're looking for. We are looking for a signal to come in to tell the controller that it's time to make fog. And when we receive that signal, we then call the driver's run fog method. That will create the fog, and then we give a little break to the fog machine by pausing. So we know how to control the fog machine, but we still need to detect nearby trick-or-treaters. And the way that we do that, as Angelica would love, is motion sensors. Looking at the motion sensor code, fortunately, GoBot has a built-in driver. So all we have to do is instantiate that motion sensor driver, define a work function, and return the GoBot robot. If you look at the work function, that's where the magic happens. We wait for a motion-detected signal, and when that signal on the sensor triggers, we then send a fog signal. And that signal goes from the motion detector down at the bottom of the hill all the way to the fog controller up at the top. And we get some fog. But we are still missing a piece, because we can make fog with the fog controller, and we can watch for the trick-or-treaters nearby, but we don't have a way to get that signal from the bottom of the hill all the way up to the top of the hill. And this is where things get scary. Because wouldn't you know that I had a couple Raspberry Pis in the closet, and wouldn't you know that Raspberry Pis are in containers, and wouldn't you know that if you spend enough time in the cloud, everything starts looking like a Kubernetes workload. So I took those Raspberry Pis and I containerized my GoBot robots, and I installed K3s on the Raspberry Pis to make a lightweight Kubernetes cluster. And I installed the NATS message bus Helm chart on that cluster so that when trick-or-treaters approach the motion sensor triggers the NATS message, which goes to the fog controller at the top of the hill. The fog controller receives that message, calls the driver's run fog method. The run fog method grounds the 4th pin on the fog machine, and we make fog, all to entertain and delight those trick-or-treaters on the way to the door. And they lived frighteningly ever after. Thank you very much.